In this video, let's talk about Linux Wi-Fi device roaming threshold. This is the fourth video of the series. If you haven't watched my first video, I strongly recommend you to take a look. That will explain the context for this particular video. You may ask, it's not like Apple devices or Android or Windows. For Linux, there are no many people using Linux laptops. What's the point to have a video talking about Linux Wi-Fi roaming, right? Granted, there are no many Linux laptops, but there are a lot of IoT devices which are rarely running on Linux. For example, your smart plugs or Wi-Fi cameras. They also have the Wi-Fi roaming needs. On the screen, I show you two Wikipedia documents: Network Manager, WPA Supplicant. So Network Manager is a daemon. It's widely installed as the default network device manager in many Linux distributions. WPA Supplicant is a cross-platform, very popular implementation of the IEEE 11i supplicant standard. Many people also choose to run WPA supplicant in their mobile Linux devices. Even if when we talk about Network Manager, we cannot avoid WPA supplicant because in my understanding, Network Manager simply wrap the WPA supplicant. The Wi-Fi part is implemented using WPA supplicant. Unfortunately, the way to configure WPA supplicant, you want to use a configuration file where you can customize, you can configure how the roaming works. But for Network Manager, it hides the configuration file and it even hard-coded the Wi-Fi roaming threshold. So which makes it very hard to understand how the default behavior for Wi-Fi roaming works. As I mentioned, there's no WPA supplicant configuration file for Network Manager, and I am not aware of any way to customize the roaming behaviors. I did read the source code for Network Manager, and if I search simple, you will find this piece of code, and it's inside the supplicant config add bgscan. Bgscan is background scanning. It's a very important configuration in the WPA supplicant. And as I mentioned, Network Manager simply doesn't use the configuration files from WPA supplicant. Instead, it hard-coded in the same way as the configuration files of WPA supplicant. See the line? It says bgscan equals to simple 30 minus 70 and this huge number. The way to interpret it is, if your Wi-Fi signal strength is lower than minus 70 dB, your Linux machine will scan the Wi-Fi network every 30 seconds. Otherwise, it will only scan the Wi-Fi network every 24 hours. That's the default setting, and it's hard-coded. This is my lab environment. I use two UniFi access points. This Linux laptop is originally connected to the left one, and I will handhold this laptop, move to the right side one. During the roaming, I will hold another laptop just to run sniffer to capture the Wi-Fi frames so that later we can look into deeper to check what happens under the hood using Wireshark. During the roaming, the Wi-Fi signals from the left side one will be weaker and weaker, and from the right side one, the signal will be stronger and stronger. At some point in the middle, the roaming will happen. So what we want to measure is when the roaming happens, what's the RSSI all the signal strengths. In this video, we are talking about the Linux operating system. So we need to find out a way to monitor the access point change and the Wi-Fi signal change. In Linux, one way to tell the signal strength is through Linux kernel status. Let me display the wireless network information. So you can see we can get the level which is in dB. So currently I have minus 34 dB signal strength. Unfortunately, we are missing one thing, which is the BSSID. By using that, we can tell which access point the Linux machine is connected with. But I don't see it in this result, so I cannot use this way. So the other approach is I use the IW command. I display this device information. Where do I get this device ID? You can see it's even included in the previous command output. Let me write it. Okay, it returns exactly what we want. See here, it indicates the SSID, the frequencies, and the signal strengths, and the BSSID. This is the access points BSSID. That's what we want. Only two things I am interested in this video, BSSID and the signal strength. How I can only display these two particular lines, simply use grep command. Basically, I want to see the lines with this string or this string. Let me write, yes, it returns the exact lines I want to display. So then the only thing left is when I move from the left side access point to the right side one, I want to continuously monitor the change. How I can do that? I simply run it with watch command. Basically, I'm saying every half second, refresh the result. Let me do it. Yep, that's exactly what we want. I'm going to handhold my laptop, move from the left side access point to the right side one. As long as this BSSID here is changed, that means the roaming happened. Then we will note down the signal strength to see whether this value is the same as what we found in the source code, which is hard-coded in Network Manager. Now let's briefly talk about the access points side settings. This is the UniFi network controller. As you can see, the two APs are shown here. If I check the SSID setting, I only have one enabled here. It applies to all the APs. I only enabled the 5 GHz Wi-Fi band, disabled all the fast roaming related setting. That's it in the SSID side. If we check the individual access point, for example, this U6 Enterprise for 5 GHz, you can see I forced the channel width to 80 MHz and manually selected channel 36. For the other access point, I made the same channel selection. In real world, you want to avoid using the same channels for different APs, right? But just to make the Wi-Fi frames capturing easier, I am using the same channel. It won't impact the conclusion of the video, but will make the testing easier. Okay, the other setting I want to highlight is the roaming happens due to two possible reasons. One is the AP can kick out your device because your device has too weak signals. And the other reason is your Wi-Fi device can take the initiative to start the roaming by itself. So what I said here, just to exclude the factor that your device roams just because your AP kicked it out, right? I want to exclude that possible factor. So I set the minimum RSSI to a very, very low value so that long before you reach this weak signal, your device should already roamed. Okay, that's the reason I set the minimum RSSI. Let's start the testing. I am holding the Linux laptop and now it's connected to the U6 Lite access point. For your convenience, I put the MAC addresses for the 3 different devices on the screen. I am moving away from U6 Lite towards the U6 Enterprise. Fast forward. Now as you can see, the signal strength already dropped under 70 and the roaming still hasn't happened. Fast forward, give it some time. Okay, finally you can see the BSSID is changed and the signal strength is much better because the roaming just happened. From the UniFi network controller, you can also see now the Linux laptop is connected to the U6 Enterprise. Because the roaming took such a long time, let me do another round of testing. This time let me move away from U6 Enterprise towards the U6 Lite. Let's see how the roaming works this time. Fast forward. Okay, the signal strength was under 70 already. It seems the similar thing happened. It's still not roamed yet. Give it some time. Fast forward. Okay, finally the roaming happened. Now the laptop is connected to the U6 Lite. Let's discuss what happened in the two roamings. I opened the captured Wi-Fi frames using Wireshark. Let's see when the two roaming happened. The way to find out is to filter on EAPOL, which means the four-way handshakes. As you can see, two sets of four-way handshakes because we had two roamings happen. Note down the timing in the first column. So the first roaming happened at about 97 seconds. The second one at 218 seconds. Let me filter on the laptop's MAC address. You can see it's pretty quiet before 85 seconds. Linux laptop sent out a broadcasting probe request asking about information for SSID ZRSSI. That's the one we used for this testing. Who responded? The first one from A8. That's U6 Enterprise, then B6 from the U6 Lite. So both access points responded. Starting from 96 seconds, the Linux machine started the roaming because the authentication happened. Then, of course, followed by the four-way handshakes. Then the roaming was successful. The most surprising thing to me is the huge gap between the probe request and when the roaming happened. There were more than 10 seconds gaps. So that explained why we need to wait for 50, 60 seconds until the roaming really happened. At this point, 85 seconds, the Linux machine started trying to roam. Why? Because of the threshold setting. When the signal strength was under 70, for every 30 seconds, Linux will scan the Wi-Fi environment, try to roam, right? At this time, Linux tried to roam. Then it received the responses immediately. For some reason, it waited for more than 10 seconds. So that's why the whole process takes longer than 30 seconds. And let's check the second roaming. It happened at about 218 seconds. This time is even stranger. See, the authentication happened at 218, which means at this time the Linux machine already started the roaming. But for some reason, it sent out another probe request and then received the responses. Apparently, this probe request and the probe response didn't help because the roaming already happened beforehand. Before this authentication, I don't see any probe request. Apparently, Linux reused whatever information it had. Remember, it's the second roaming already, right? So the Linux already had the information for the U6 Lite. That's why it started roaming even without sending the probe request. So this is the second surprise to me. If you watched my previous videos about Mac OS and Windows roaming, compared to them, the behavior for this particular Linux laptop, the Wi-Fi roaming was very, very sticky. It need to wait a long time till it rescan the network. Then it needed to think about it for a long time and then finally do the roaming. Okay, these are my observations by looking into the captured Wi-Fi frames. Let's talk about one more thing about neighborhood report. I won't spend time on explaining the details. If you are interested, check my previous video for Mac OS Wi-Fi roaming. Let me directly check whether we have neighborhood report for the Linux machine. This is the filter. So basically, I want to see the neighborhood report and the response from or to this Linux laptop. As you can see, nothing's here. Basically, another interesting finding is apparently for this Debian Linux I'm using, by the way, it's already the latest version. It seems it hasn't implemented the IEE standard for neighborhood report. So that's another thing. It may slow down the Wi-Fi roaming performance for Linux. Okay, this is the end of the video. Thanks for watching.